So, hello dear students. In the last class we talked about degrees of freedom and mobility, and uh, what is degrees of freedom of a body in space, of a point, what is redundant, hyper-redundant, continuous, all those things we discussed. Now, I would like to bring to your notice few examples. Let's say if you have a revolving joint, here you can see this joint is able to revolve about this axis Z. So it is having, you can say it is having 1 degree of freedom, here you can say, and we have one sliding joint, here you can see. So this can translate only along this direction, so it is also having only 1 degree of freedom. And if we have a cylindrical joint here in this example, and then it can be termed as 2 degrees of freedom. Okay, and if I have a spherical joint, okay, like here it is a spherical joint basically, so it is having 3 degrees of freedom. Remember, it can be rotated along all the spatial coordinates. Okay, for example, if you are going in a bike or a scooty, you might have seen your mirror, okay, and they are fixed in a spherical joint. So it spherical joint has 3 degrees of freedom, remember. Okay, likewise if you take a Gammon roller mechanism, okay, here this portion is the roller actually, okay, this is a roller and this one is your cam, so it is having 2 degrees of freedom. And if we consider 2 gears in mesh, okay, and let's say this is a pinion and this is a gear, and they are in mesh with each other. Okay, so in this case they will have 2 degree of freedom. These are the basic examples we come across, okay, during our day-to-day life. That's why I thought I should discuss these joints with you. Now, also in the last class we talked about a kinematic chain, okay, and we discussed about only 4-bar chain. In general, we have in machine dynamics 3 possible kinematic chains are there. One is 4-bar chain, which I have already told you. The first link will be connected to the last link. Another one is your so proceeding further, let's say 3, as I told you, 3 kinematic chains are possible. One is 4-bar chain, single slider crank chain, double slider crank chain. In this class we will discuss about what are the possible inversions of these kinematic chains. So 4-bar chain, with this we have already discussed. Let's say it is having 4 links, okay, 4 links all are turning pairs, okay, and let's say this is link 1, link 2, link 3, link 4, and as a linkage we need to fix one link here. So here link 1 is fixed here, we can see, and if we rotate one link, okay, which will be our crank, and we'll get possible uh, relative motions among them. So what are the possible inversions of a 4-bar chain? These are the 3 possible inversions. Okay, remember, these are the 3 possible inversions. First is your beam engine, which is also known as crank and lever mechanism. Second inversion possible is coupling rod of a locomotive. Then third inversion is your Watt's indicator diagram. So these are the three inversions possible. Now coming to the first inversion, this is the basic schematic of a beam engine. Here you can see, okay, it essentially consists of the first link, which is the frame, and it is fixed, okay, so as the cylinder. Here you can see the second link is the crank, and crank is connected to this link 3. Here you can see, and the lever is the link 4. To the end of the lever, one piston rod is connected with the piston. So beam engine is one of the inversion of a 4-bar chain, okay, and it consists of 4 links. Okay. It is also known as crank and lever mechanism. Okay. As I told you, it is also known as crank and lever mechanism. So in this mechanism, the crank rotates about center A. This is the center A about which the crank AB rotates. Okay, the lever oscillates about D. This one is the lever. Link 4 is the lever, and it oscillates about this point D. The end of the lever CDE is connected to a piston. Okay, is connected to a piston through this piston rod. Okay, through this piston rod it is connected to this piston. Okay, so this is the piston, and which reciprocates due to the rotation of the crank. Okay, so the purpose of this mechanism is to convert the rotary motion to reciprocating motion. As you can see here, the rotary motion of this crank, okay, rotary motion of this crank is converted to the reciprocating motion of this piston because of this mechanism. Okay, it is known as beam engine. Now the second possible inversion of 4-bar chain is coupling rod of a locomotive. This we might have come across in our practical life, and it is also called as a double crank mechanism. Okay, you all of you might have seen a rail engine, okay, a rail bogie also. So what happened in a rail bogie, all the wheels, that means the leading wheel and the trailing wheels, are connected, okay, by means of a coupling rod. And this is the coupling rod, you can see, and the coupling rod of a locomotive is also known as double crank mechanism, as shown in the figure. In this mechanism, the link AD, here you can see the link AD, this is AD and this is BC. Link AD and BC are of same length, and they act as cranks and are connected to respective wheels. Okay, they are connected to the both the leading and trailing wheels. The link CD here is acting as a coupling rod, and link AB is fixed. Okay, so this coupling rod is connected to both the leading and the trailing wheels. Here you can see, and because of the presence of two cranks, it is known as double crank mechanism. Okay, it is also known as double crank mechanism, right? Double crank mechanism. Now what is the advantage of this? This mechanism will help to maintain a constant center of rotation, okay, of both the cranks. Then this mechanism is used to transmit the rotary motion from one wheel to the other, basically. If the leading wheel is powered first, then the motion of the leading wheel will be transferred to the trailing wheel because of this presence of this coupling rod. Okay, this is the advantage. Okay, then the third possible inversion is of 4-bar chain is Watt's indicator mechanism, or it is also known as a double lever mechanism. Okay, Now a Watt's indicator mechanism schematic is here, you can see. Now is also known as a double lever mechanism, as I told. The four links are here, we can see. This one is the we have a fixed link, and this is link 3, okay, and this part is link 4, okay, and fixed portion we are taking as link 1 here, okay. So as this, and this part, that is your CB, is link 2. Now the two parts of the link BFT, okay, this is termed as a single link BFT. The two parts of the link BFT, that is BF and FD, form one link, as there is no relative motion between them, remember, okay. And links CE and your BFT acts as lever. That means this link 3 and this BFD, the link 4, acts as a lever. Now the displacement of BFD link, okay, displacement of this BFD link, link 4, is proportional to the pressure on the indicator plunger. Okay. If your displacement increases, the pressure will also increase. Okay, remember this, because this end is connected with the indicator plunger through this rod. Okay. Now single slider crank chain. Okay. So this is the basic schematic of a single slider crank chain. Okay, basic schematic. Essentially it consists of a frame, that is link 1 is fixed here, and we have this crank, okay, link 2, connecting rod is link 3, crosshead, the translatory part crosshead is link 4, and which is connected to the piston rod, and finally with the piston, and the piston is reciprocating inside the cylinder, okay, and the crosshead moves within this guides, okay, within these guides. So the single slider crank chain is a basic modification basically of 4-bar chain mechanism. It consists of one sliding pair and 3 turning pair. What is the sliding pair here? The crosshead, that is the link 4, and link 1, which is the fixed one, okay, regarded as a sliding pair, and others links are regarded as your turning pair, right? So one sliding pair, okay, one sliding pair here, and 3 turning pair. So it is usually found in reciprocating steam engine, okay, mechanism, and it converts the rotary motion to reciprocating motion and vice versa. As the crank rotates, the crosshead reciprocates in the guide, and thus the piston reciprocates in the cylinder, as I told you. Okay. So the rotary motion of this crank, as you can see here, rotary motion of this crank is converted to the reciprocating motion of the piston here. So this is single slider crank chain. Now what are the possible inversions of this single slider crank chains? These are the possible inversions. So first inversion is your pendulum pump, also known as bull engine. Second possible inversion is oscillating cylinder engine. Okay. Then third is your rotary internal combustion engine, also known as NOM engine, GNOME, NOM engine. Fourth one is your crank and slotted lever quick return mechanism. Fifth one is Whitworth quick return mechanism. We will discuss all these 5 one by one. Okay. So these are the 5 possible inversions of single slider crank chain. Now, first is your pendulum pump, also known as bull engine. So, the bull engine is the inversion obtained. In this case, the inversion is obtained by fixing the cylinders. Here you can see, okay, by fixing the cylinder. So, when the crank rotates here, so link 2 is the crank here. Okay. When the crank rotates, the connecting rod oscillates about the point A. Okay. So, this is the connecting rod here. You can see it oscillates about this point and the piston reciprocates. And the piston reciprocates inside the cylinder. This one is the piston. Okay. Piston here. So, it is used to supply feed water to the boiler. In power plant, generally we use boiler, okay, and this mechanism is used to supply the feed water to the boiler. Now, second possible inversion is oscillating cylinder engine. Okay. Oscillating cylinder engine. The basic schematic, as you can see, we have a crank, a piston rod, and piston and a cylinder. Okay. Connecting rod is fixed here. Oscillating cylinder engine is used to convert the reciprocating motion of piston to rotary motion of the crank. Okay, remember. So, in this case, the connecting rod, that is the link 3 forming a turning pair, is fixed here. So, when the crank rotates, the piston reciprocates and the cylinder oscillates at a point A, okay, at a point A to the connecting rod. Now, third possible inversion is rotary IC engine, or also known as your NAM engine. Okay. Gas turbines are nowadays used in aviation, and it essentially consists of 7 cylinders in one plane. In a single plane, 7 cylinders will be there. Here you can see 1, 2, 3, 4, 5, 6, in total 7 cylinders are there. The crank is fixed here, and when the crank rotates, the piston reciprocates inside the cylinder. Okay, the piston reciprocates inside the cylinder. So, here you can see this is another example with 3 cylinders here, 1, 2 and 3, and all rotate about this fixed point here. Okay. So, the reciprocating motion of piston inside cylinder in a particular sequence is obtained. Okay. Now, fourth possible inversion is crank and slotted lever quick return mechanism. This is one of the very commonly but most important inversion we used to get, okay, from the single slider crank chain, and this you will find in shaping machine. In workshop, if you visit shaping machine, there you will find this mechanism. It reduces the total cutting time by reducing the ideal period of returning stroke. Okay. So, essentially it consists of a ram, okay, a ram to which the tool is connected, okay, on the tool post, and the ram is connected with the connecting rod. Here you can see this is the connecting rod. Then the end of the connecting rod is connected to a slotted bar. Okay, this AP, this is A here, this is P here. So, this is a slotted bar which is connected to the connecting rod. Inside the slotted bar we have a slider, okay, which is our link 1, and the slider is connected with the crank, which is our link 2. Okay. Now, the entire line of stroke, okay, entire line of stroke of this ram can be represented from R1 to R2, right. Now, link 3 is fixed here from A to C. Okay, you can see here this link 3 which is fixed. This is our link 3. Now, the crank and slotted lever mechanism is used in slotting machine, shaping machine, etc., and in IC engine also. So in this mechanism, as I told, the link AC, that is link 3 forming a turning pair, is fixed, and link 3 is corresponds to the connecting rod, okay, of the reciprocating steam engine. The driving crank CB, okay, here you can see the driving crank, this is C, this one is B, okay, this point is B. The driving crank CB rotates about a fixed point C at constant angular speed. A slider block is attached to the crank pin at point B, and it slides along the slotted bar AP, thereby causing an oscillation to it. Okay, the AP used to oscillate during this period, and as it is pivoted about a point which is point A here. Okay, this is the pivot point. The slotted link PR, okay, the link PR here you can see, this is the slotted link PR, transmits the motion from slotted bar AP to the ram, okay, which carries the tool and reciprocates along the line of stroke R1 to R2. Okay, the line of stroke R1 R2 is perpendicular to AC. Okay, the line of the stroke R1 R2, which I shown you, is perpendicular to AC. Now the extreme positions AP1 and AP2 are tangential to the imaginary circle, if you see from the schematic, and the forward or the cutting stroke occurs when the crank rotates, okay, from its position CB1 to position CB2 through an angle beta in clockwise direction. Okay, in clockwise direction. So, and the return stroke occurs. The return stroke occurs when the crank rotates from one position CB2 to CB1, okay, through an angle alpha in clockwise direction. Okay. So this is the return stroke alpha, this is the return stroke beta. Here you can see from this position to this position it is beta, and from here to here it is alpha, right. So as the crank has a uniform angular speed, so the ratio of time of cutting stroke to the time of return stroke can be represented by these angles beta and alpha. So it is beta by alpha, or we can write as beta divided by 360 minus beta, or we can mention this equation as 360 minus alpha divided by alpha. So the tool travels a distance from R1 to R2 during the cutting and P1 to P2 during the return stroke. Therefore, this R1 R2 is equal to P1 to P2, which is equal to 2 P1Q, okay, or it can be represented as 2 AP1 sine 90 minus alpha by 2. You can see from the geometry, or we can say in simple it is equal to 2 AP into CB by AC, the ratio of CB by AC. Okay. So this is the fourth possible inversion of single slider crank chain. Now coming to the fifth possible inversion, which is known as our quick return motion mechanism. Okay, and this is also used in shaping and slotting machines. Okay, in the mechanism, the link CD, which is L2, that is link 2, forming a turning pair, is fixed here, and the link 2 correspond to the crank. Okay, earlier we have fixed the connecting rod, here we are fixing the crank. Okay. the driving crank CA, okay, the driving crank CA, that is our link 3, rotates at an uniform angular speed, okay, angular speed. The slider here, the slider is link 4, you can see in the figure. Here in the slotted bar we have this slider, okay. The slider attached to the crank pin at A slides along the slotted bar PA, which is our link 1, which oscillates about this pivot point D. Okay. The connecting rod PR carries the ram R to which a cutting tool is fixed. Now, the motion of the cutting tool is constant along the line RD. Here you can see it is constant along the line RD, okay, between D and R. Now, which is perpendicular to CD. Now, same here you can obtain the ratio between the time taken during the cutting and return stroke can be obtained as alpha by beta. So, we can write alpha divided by 360 minus alpha, or you can express this equation as 360 minus beta divided by beta here. Now, coming to the third possible kinematic chain, which is our double slider crank chain. Here a kinematic chain consisting of 2 turning and 2 sliding pair is known as a double slider crank chain. Here you can see we have 2 sliders, this is one slider, this one is another slider. So, link 1 and link 2 okay, forms one turning pair, okay, a turning pair, and this is link 1, this one is or link 2, they form a turning pair. Similarly, link 2 and link 3 forms another turning pair, this 2 and 3 forms another turning pair. Link 4 forms one sliding pair, okay, and link 3, 4 forms the second sliding pair, means this 3 and 4 forms one sliding pair, this 1 and 4 form the second sliding pair, okay, second sliding pair. So, in total we have 2 turning pairs and 2 sliding pairs here, okay. Now, what are the possible inversions? Possible inversions of this double slider crank chain are elliptical trammel, okay, elliptical trammel, Scotch yoke mechanism, this is the YOKE, okay, Scotch yoke mechanism. Then Oldham's coupling. These are the 3 possible inversions of double slider crank chain. First, coming to this elliptical trammel. Elliptical trammel can be used to draw ellipse, okay. The inversion is obtained by fixing the slotted plate basically, which is our link 4, okay. This is the slotted plate, you can see this shape, slotted plate, and this fixed plate link 4 has 2 straight grooves cut in it at right angles to each other. Here you can see here in this fashion, as I told. The link 1 and link 3 are the sliders. This is link 3 and this one is link 1, okay, sliders and form a sliding pair with link 4, okay, which is fixed. The link AB, that is link 2, is a bar which forms a turning pair with link 1 and 3, okay. So, when the link 1 and 3 slides in the respective groups. Okay, when these two sliders, slider 1 and slider 2, slides in the respective groups, okay, here and here, any point on this link 2, okay, any point on this link 2, this is our link 2, such as point P, for example, will trace an ellipse on the surface of link 4, on the surface of link 4. So this ellipse will be traced if we consider any point on the second link or link 2. Now for the ellipse drawn by point P, AP and BP are the semi major axis and semi minor axis respectively. Okay, and let us consider from this figure, here you can see that the bar link 2 is inclined at an angle theta. Okay, this is inclined at an angle theta with the horizontal. So the coordinates of point P on link BA can be expressed as let us say PQ and PR. You can see here PQ and PR, which is PQ is equal to AP cos theta and PR will be equal to BP sin theta. Or you can express this as X by AP will be equal to cos theta, Y by BP will be equal to sin theta. So squaring and adding this equation 3 will have x square by AP square plus y square by BP square will be cos square theta plus sin square theta, which is equal to 1. Let us say this is our equation 4. So this equation 4 is the equation of ellipse actually. Hence the path traced by this point P is an ellipse, okay, whose semi major axis is AP and semi minor axis is BP. Okay, now if P is the midpoint of link BA, then your AP will be equal to BP and the equation 4 will be x square by AP square plus y square by AP square equal to 1, or you can say x square plus y square is equal to AP square. So this will be the equation of a circle. Okay, now coming to the second possible inversion, which is called as your Scotch-Yacht mechanism, and the basic schematic is given here. You can see this is the basic schematic. Okay, now Scotch-Yacht mechanism is used for converting the rotary motion into a reciprocating motion. Now here the inversion is obtained by either fixed link 1 and link 3. Okay, here you can see. So in this case link 1 is fixed when the crank, that is link 2, rotates about point B as center, the piston reciprocates. This is the piston. Okay. Here you can see this is the piston and this one is our cylinder. So the piston reciprocates inside the cylinder. Now the third possible inversion of this double slider crank chain is Oldham's coupling. Okay, Oldham's coupling. The basic function of this Oldham's coupling is to transmit the motion between two parallel non-coaxial shafts. Okay, to transmit power between two parallel but non-coaxial shafts. Okay, here you can see we have a driving shaft A here and a driven shaft B here, which are parallel to each other. Okay, this is the axis of shaft A, this is the axis of shaft B, which are parallel to each other but are non-coaxial. Okay. So this inversion is obtained by fixing link to the shafts are connected by means of two flanges. Here you can see link 1 and link 3 rigidly fastened at their ends. Link 1 and link 3 form turning pair. Okay, you can see with link 2, and these flanges these flanges have diametrical slots cut in their inner faces. The intermediate piece, which is link 4, which is a circular disc, have two tongues T1 and T2 at right angle to each other. Link 4 can slide in these slots of the flanges. Okay, let say omega, if omega is the angular velocity of each shaft in radian per second, and d is the distance between the axis of shaft in meter. Okay, in meter, then the maximum sliding speed of each tongue v will be equal to omega into d. Okay, omega into d. So this is all about all the possible inversions, okay, uh, which we can obtain from these three kinematic chains, which are our 4-bar chain, single slider crank chain, and double slider crank chain. Hope you gain some knowledge out of this. Okay, thank you.